Okay. So good morning, everyone. Today we have our speaker, Dr. Hardik Gohel. He is Assistant Professor and Director of Research, Department of Computer Science and Engineering, University of Helford. Okay. He have completed his PhD from Computer Science from University of Helford, United Kingdom. His subject on the area of the specialization is artificial intelligence and cyber security. His research areas include data science, digital health, virtualization, social media. Dr. Gohel has extensive experience of in the artificial intelligence, and his research projects have involved cyber test automation and monitoring, smart bandage for own monitoring, big data for security intelligence, trustworthy cyberspace for security and privacy of the social media, predictive maintenance for nuclear infrastructure, and database and mobile forensic infrastructure. Dr. Gohel is also working on how to prepare quality diversified workforce for artificial intelligence in science, technology, engineering, and mathematics education. His independent research program is inspired from his graduate and postdoc studies. He is interested to design, develop robust artificial intelligence and cyber security solutions to make human life better. Dr. Gohel activity working with United States Federal Funding Agency and National Labs for Research Collaboration. He is also interested in linkage and MOU with government, academia, and industry to foster individual institutional partnership in natural and sustainable manner. Now I'll welcome Dr. Hardik Gohel. Sir, please start your session, sir. Thank you. I think, sir, your mic is off, I think. Hardik, sir, your mic is off. Yes, from here on.
Oh, okay. Oh, yeah, that was a mistake. Now, can you hear me?
Yes, sir. We can hear you.
Okay, yeah. I mean, that was a mistake. Sorry. Hmm. Yeah, I think now it's good. Okay, so my voice is audible, right?
Yes, sir. Yes, sir. Pretty much
Okay,
audible.
perfect. Yeah. So very good morning to all of you. And today I'm going to present on IoT and cloud and fog computing. So initially, I was thinking to include the project of IoT with respect of the cloud computing, and also like we are working on the edge computing. So I was having some concept to present in a fog computing as well. But then I realized, like due to COVID-19, it would be beneficial if I discuss the applications of the IoT in a cloud in a healthcare applications. So that is what I have incorporated in my presentation. So right now we are working on many healthcare solutions, and that all solutions has been funded by the federal government and also like state agencies. And we are having numerous research going on with respect of like remote healthcare solutions. So that is also I have included in my presentation. Instead of like general IoT, I have focused on IoMT, which is Internet of Medical Things. But if anybody is having questions related to IoT solutions and how we are, doing in-premises, cloud, and hybrid solutions, I can answer. So before I start and discuss about IoT and IoMT, here is a brief about me. That my name is Hardik Gohal, as I have mentioned, and my academic qualification, I have done my PhD in computer science in 2015 with the dissertation title of Investigator Study of Social Media and the Development of Social Secure Web. My areas of specializations are artificial intelligence, cybersecurity, digital health, virtualization, and social media. In my research portfolio, I have done like four books publication, two book chapters, and more than 50 publications in the journal and proceedings of international and national conferences. And I'm also working with many universities in India, China, England, and also in US for research and development collaboration and collaborative publications. Before I jump into like IoT, IoMT kind of things, let me brief about the research that I have done in my PhD. So in my PhD, I have started doing something a little bit research in the social media, and in that research, what I have started with, and what I have studied with my literature study, that the social media is more focusing on the unstructured data storage, because in 2019 there were first time the concept come that how we can use and store unstructured data, and that was given by the social media. Let's say for example image data, audio data, video data. So how we can store those data at one place. So there will be like unstructured data storage was one challenge that everybody was working on. The second one was like social media unstructured data management. So let's say once you have a stored data, how you would manage the data. And another thing that everybody was focusing on, like what are the efficient ways of the social media data retrieval. So these are the research gaps. So these are the literature studies that I have gone through and found the research gap, that there is a still ways to obtain critical information from the social media. And as the social media was very much new, so nobody was focusing on the security issues of the social media. So I have decided to design and develop the solution, which is known as a social intelligence. That means apply AI, artificial intelligence, on the social media and develop the social intelligence. So there's a social intelligence that you are seeing here is a combination of the social data mining, semantic web or semantic social media, and social media data retrieval and warehousing. So that was the concept of the solutions that I have developed and designed in my PhD. Here is a research framework that I have designed and developed. So in this research framework, you can see that it is more focusing on like only two social media. The first one is the Facebook, another one is the Twitter. I have, there are like, there were already ready-made API available for Twitter and Facebook, but it was not that so useful at that time. So I have designed and developed my own API and try and collected the important data from the social media. And I have used R analytics techniques and collected data and their analytics into the SQL Server. And I tried to visualize it by using the dashboards of the social intelligence and the detection of suspicious messages that is happening in the chatting activities. So the table AU that you are seeing, the social intelligence, it was showing the all the clusters that is belongs to the different social medias and their connections. And the another that you are seeing, that is the detection of the suspicious instant messages activities that is happening in the social media, especially Facebook Messenger chatting. So that was the concept of the research framework. The research framework was very broad, but this is a spatial design of the research framework, which is like easy to understand and explain as well. So now what are the broader impact of the research and the outcomes that what I'm discussing here? So you can see the gaining the perceptions from the large amount of the data floating on the social media. The second one is the perform data sampling and of the social media and analyze to render useful results that can be useful for the medical governance and also businesses. Monitor suspicious activity or other e-crimes of the social media, instant messages, and you can also predict the healthcare trends and economy by using this proposed framework. So that is what all about my PhD framework or the research that what I have done. So before we jump into like IoT and edge and fog and cloud and all those things, so let's see what are the current trends. So the current trends that you would be seeing in the market right now, that it is AI at edge. So that is the auto sensing. So you will be seeing like, there is a edge computing is more important nowadays. So if you are talking about like, computation, so let's say there are so many solutions available in the market that let's say they are collecting the data. So there are the devices, traffic detections, autonomous driving, location tracking, augmented reality, virtual reality, safety monitors. These all kind of solutions available in the market. But these all solutions are collecting the data, and data are going to store in the into the cloud. So what we are proposing here, that we are proposing that instead of data going into the cloud, can we analyze those data within the devices, and that we call edge, AI at edge, or you can say AI at fog computing. So here what we are doing, like we are trying to analyze the data, performing machine learning and deep learning and all computation over the devices instead of sending it into the cloud. And that is known as the AI at edge. And nowadays, like a lot of companies like Microsoft, Google, and Amazon, they are working on this kind of solutions. The second one is the cognitive robots and drone. So that is also one kind of solutions that is happening. Lots of research is going on over there. So the cognitive robots is like, the robots with automatic learning and sensing. So there are so many solutions and the companies nowadays in the market that they are applying reinforcement learning onto the robots and drone. So how that works actually. So by applying reinforcement learning, it is working on the base of the trial and error. So drone has been designed for the initial learning, and then based on the experiences it is getting from the experiment, it learns. So that is a cognitive robots and drone. The another current trend that I would like to mention is a cyber physical system. So the cyber physical system is a combination of the system where you are connecting all these devices and hardware with the internet. So consider the situation like, there is the Internet of Things and RFID, the satellite network, mobile network, wireless sensor network, also the embedded system. These all things are connected with each other, and they are connected using the internet, and that is known as a cyber physical system, which is the connections of the all these hardware and software systems through the internet. So that is also like, current trends happening in the market. The another one is the adversarial machine learning. So the adversarial machine learning in the sense like, is that it is like, trying to manipulate and make the bias and the training such a way that it will predict something instead of something else. So how does it work? So you see the left is a suit, left image that is showing the suit, and the right image is showing the wig after the perturbations in the middle. So what we are doing over here, that we are submitting one images and we are saying that this image is representing something that's a suit. Okay, but the thing is like, when you are manipulating the data and trying to manipulate the machine learning model and try to attack the model and fitting the data into the model, which are not so useful for the real time or appropriate training of the model, what it does, it will train with some biases. And that is called the adversarial machine learning. And that is what all current trends like people are trying to manipulate the machine learning and deep learning model that is already implemented on the edge, which is the fog computing and IoT devices, and also the cloud computing. So Internet of Things that we know, like, there are like, different things. For example, if we are talking about the smart home automation system, so let's say the fridge, TV, and microwave, oven, they all are connected with each other using the internet, and that we call as the Internet of Things. But nowadays, since like last 6 or 8 months, or let's say maximum 1 year, there is one additional trend in the market of the research, then that is known as the Internet of the Medical Things. So what is this Internet of Medical Things? Let's see a little bit about it. So the Internet of Medical Things that impacts on the healthcare. Okay, so more than like 500,000 medical technologies are currently available in the market, and after like half of the solutions, like 200,000, they came after March 2020, when the pandemic has started. So what is Internet of Things? It is having the ability to collect, analyze, and transmit the health data, and IoT tools are rapidly changing the healthcare delivery, and also like provide the diversified solutions. So here you see that IoT is a connected infrastructure of the medical devices, software applications, health systems, and services. If we are talking about the Internet of Things, it is the same thing, like connected infrastructure of the devices, software applications, and the systems and the services. But here in IoT, we are focusing on one thing, that is a medical and health. So what does it do? It is a sensor-based tools, including a wearable and a standalone devices for the remote patient monitoring. And it is also like you can say internet connected medical devices plus patient information is equal to the IoT system. So the patient information is having all those data, and the internet connected medical devices, for example, let's say you are using the smart Apple Watch, okay, smart EKG system and a smart X-ray system. So there's all kind of system, they are connected with each other using the internet, and they are collecting the patient's information and storing the data about the patient. That calls IoT ecosystem. So here you see the future of the IoT. So like IoT future is for sure there, but IoT future is kind of very promising. The reason, like nowadays, like it is required, not required, but like say it is mandatory that you have to have the solutions of the healthcare solutions where physicians can treat patient remotely. And due to this pandemic and COVID-19, it is mandatory to maintain the social distancing. And that is the reason, like IoT devices solutions are really rapid growth and required in the market. So you see the global IoT market was valued at 44.5 billion in 2018 and expected to grow in 254.2 billion in 2026. And that is what all the research that what have done. You can see there is a rapid growth of the smart watch and smart shirts, AI integration to connected devices to provide a real-time and remote measurement and the analysis of the patient data. And there is also like a need of the connectivity to care and the insurance provider. So the thing is like nowadays, in other countries, insurance and caretakers are not mostly connected at at usual, but in the United States, like it is there are like there is a disconnectivity between care provider and the insurance provider. So by using these IoT devices, you can see like there will be a connectivity between the care provider, who can be the hospitals, physicians, and the insurance provider. And it will also enable clinicians to monitor and treat the patient remotely, which is the big need of the COVID-19. So these are the major aspects or the impacts or you can say the importance of the future of the IoT. So I mean, this is what all about, like, the introduction part, and now I'm discussing like the projects that we at University of Houston at Victoria involved with the presentations. So the first project that we are involved is nano-enabled biosensing and AI. So what does it mean over here? So you can see, like, biosensor market in the United States is rapidly increasing, and it is expected that the budget of the biosensing market will go up to the 27.6 billion US dollar, and that is a need, or there is a need of, like, nano-enabled biosensing. So this nano-enabled biosensing, it is having the nanotechnology enabled to the biosensors to take the smart decisions. And there is also potential solutions by incorporating artificial intelligence. And what are the point of care testing? The actual research framework is very vast, but here I am presenting very small research framework, and that is what easy to understand. So you can see the point of care testing, like, glucose monitors or cardiac monitors, and also like blood gas electrolytes, tumor cancers markers, and other cholesterol tests. This all kind of testing can done remotely by using this nano-enabled biosensing. And this biosensing, you do not need to plant within the human body. This can be a wearable as well. So, like, biosensings, initially it was the implantable sensors. So like you need to plant within the human body, and then it was collecting all this kind of monitoring things. Nowadays you don't need to plant, you just need to wear it. So wearable devices doing all this kind of things. But there is another trend which is going on, that not only wearable devices but also the carryable devices. So let's say device itself is detecting the issues within the patient by collecting their monitoring system and then also treating them, that what it needs to do. So let's say, for example, if there is a blood pressure is going on of the patient, then immediately it is giving a notification to the physicians of the patient, and that way, patient can get the urgent care remotely, or let's say at the clinic immediately after it has recognized by the devices. So you just don't need to, like, wait to get situation is really worst. You can take immediate care, and this nanos enable biosensing is providing that kind of solutions. The another one that you are seeing here, the next generations of the biosensors, biosensor based diagnosis approach for the personalized health wellness. So that is also, like, one additional solution. So here you will see the next generations of biosensing chips based diagnostic systems. So what does it do? It is incorporating three different technology. The first one is a bioinformatics, which is combinations of the AI and IoT. So what AI is doing, like diagnosis and monitoring, and what IoT is doing, it is also doing the continuous monitoring using the devices. So the next generation of the biosensor-based diagnosis approach for the personalized healthcare and the wellness. The second one is the health monitoring using IoT. So now we know, like, IoT is there, but what we can do in the healthcare system. So for example, let's say healthcare monitoring using IoT. So let's say in a healthcare monitoring using IoT, you can see the IoT. I mean, we have seen the IoMT, but let me, discuss very about the IoT and IoT and their use of IoT in the cloud and also in a edge. So edge means fog. Okay, so there's all kind of solutions can be there. So IoT is a giant network of the connected things. Okay, so you can see that IoT is from the connected benefits. You can see there is a device connection, data sensing, communications, data analytics, data value, and the human values that all are connected with each other. So that is known as a IoT. Now the IoT And here we are talking about the three different things: IoT, cloud, and fog. So here you see that IoT, actually, the fog is the new terminology, which is also known as edge. So we are using edge as in solutions in our proposed research projects that we are working on right now. But yeah, edge is same as like fog computing. Okay, so edge computing is the same as like a fog computing, but here you see the Internet of Things. So Internet of Things is known as a smart devices, smart vehicles, and the connected system. Just like a vehicle devices and autonomous cars, that's what we call the Internet of Things. Then the cloud, that cloud, that is a third party platform cloud, SaaS, or you can have your own platform. So that is also known as cloud. So it is having like big data processing techniques, data warehousing, and event management. But there is one fog, or we can say edge, in between of IoT and the cloud, and that is known as a edge computing. So what it does, it is doing real-time data processing and local processing. So let's say, for example, here is the wearable devices collecting the patient data, let's say heartbeat data. So every heartbeat data is not going to the cloud. Only the anonymous data, the anomalous data, and the data which is new. Okay, so not all redundant data. So let's say the heartbeats are normal. So this normal data will not go to the cloud. It will, come to the edge will processing and ignore those data. But if there is anomalous behavior, and the secondary thing is if there is any something like, new data. So let's say the heartbeat has two beats, 70 to 74 times. But let's say sometimes it is, beating within a minute 62 times only. So that is the anomalous data. So that pattern has to go to the cloud or the record storage that this kind of behavior has happened within the patient's body and the data has been collected by this wearable devices. Okay, so here you see the edge computing, which is a fog computing that allows the data from Internet of Things devices to be analyzed at the edge or fog of the network before being sent to the data center or the cloud. And how this pipeline execution works. So let's say if you are talking about the solutions, so what can be the solutions? So solutions can be at three different ways. The first one, the solution can be on the premises. The another one is solution can be on the cloud. And the third one is like, half the solution is on premises and half on the cloud. That's a hybrid. So here you see the data sources that is collecting the data. And there are different types of data that has been collected. I mean, hard data. So that can be the sound, X-ray data, that can be the images, other wound data, that is can be also the images. Okay, so the different types of data stored, and it has a data ingestion. Okay, and then from the data ingestions, what it does, it is going to the data storage, which is a secondary storage, can be the cloud as well. And from the data storage, it is going for the data visualization. But before that, it is also doing a data processing and analysis on the cloud. So this pipeline execution that what you are doing like on-premise, cloud, and hybrid, this is the actual executions of the pipeline where you can visualize the data from the raw the data that you have collected from the original sources, just like the medical devices or the you can say wearable devices. Health monitoring system design. This is what the general design. I mean, the design is a little complicated, but this is more easy to understand. That's why I have chosen to present it here. So here you can say there is the EEG, ECG. I mean the EKG that you guys are knowing about, and the EMG and the motion captures. So this all kind of human body data. It is using the interface just like Bluetooth, Wi-Fi, or let's say Zigbee, and the low power wireless links that is collecting the data by using the mobile gateway or interface, and this whole data it is transferring to the edge computing gateway, and the data which is not anomalous, and the data which is new, that goes to the long-term storage, which is on the cloud maybe, and whatever the diagnosis and alerts are there, that needs to be generated. to the patient or patient relatives or maybe the physicians or something. So this is, you can see, this is here you can see it is a combination of three different technologies. The first one is the cloud, sorry, the first one is the IoT, second one is the fog computing, and third one is the cloud. So you see there is a, in the bottom, it is the IoT, at the top there is a cloud, in between there is the edge or the fog computing. So it is a combination of three different technologies. So what are the research findings of these solutions that what we are talking here? So the research findings can be like, many. The research findings can be many actually. These are just listed here, but you can see there are so many research findings. So the first one is like, automate the patient's routine and the daily checkup. So let's say if patient needs to do like, routine and daily checkup, they don't need to go to the doctor. They can do at home and it is automated. Okay, the second one is the proposed solution decreases the communication latency. Why it is decreasing the communication latency? Because every time IoT device, let's say wearable device, they do not need to communicate with the cloud. So let's say, sending and receiving of the data between device and cloud takes a lot of time, and that creates the communication latency. But here what we are doing, like we are giving the solutions where the data can be analyzed on the device itself, and that is the reason it decreases the communication latency. It also improves, how you can say, shortens the decision making time using this machine learning and artificial intelligence model at IoT edge runtime, and that is one of the most fastest solutions that we can ever imagine in the field of the medical science. The second one is a quick actions will save resources, human life, and also assure the quality. It also like fast and real-time health data capturing from the wearable sensors and the devices. There is also like benefits of like real-time predictions by deployed AI and machine learning algorithms at AI or edge runtime gateway or IoT functions or the wearable devices. So what does it mean by specific this kind of finding? That it is giving the real-time predictions by using this AI and machine learning model. So what does it mean? Like whenever you are collecting a data, what you need to do, like what the data that you are collecting from the wearable devices, that you need to send it to the cloud. And once the data will be on the cloud, then you will fetch that data again to do that analytics like machine learning and artificial intelligence, and then again you store into the cloud, and then you use it for the visualizations or whatever the purpose you would like to use. But here in this solution, you can do the real-time predictions. You don't need to wait because it is providing the computation at the fog runtime and or the gateway, and that is what one of the functions that gives us a real-time predictions with the fastest analysis. The another one is intelligent decision on IoT edge device or the gateway, and only anonymous data is transferred to the cloud. So as I mentioned, like there is not much space wastage on the cloud will be happen by using this solution. So right now, let's say if you are collecting the data from the wearable devices and you are transferring the data to the cloud. So what happens is like let's say for example, if you are collecting heartbeat data, so it goes like 70 to 72 heartbeat sounds records every minute to the cloud. Let's say if you are collecting other types of data, so every minute, every nanosecond is collecting the data and transferring data to the cloud. So you can imagine like how much data will be going to the cloud and how much it will be occupying the space in the cloud. So here in this proposed solution, what you can do is like you can save the space on the cloud by sending only anomalous data or the new data, but the data redundancy is reducing very well by using these solutions. So that is what technology benefits of these three different technologies all together: IoT, cloud, and fog computing. The another project that we are working on, and this project is in association with the Indian company, And this is the project that is in a collaboration with the company and funded by the US India research collaborations. So the title is a lung-based element screening. So there's a lung-based element screening. That means what the problem of identifying the issues and the disease which are the lung-based disease. Okay, so what are the motivations that we have got for this specific project? So here you see there is a country like India or rest of the world. There are more than 12 million or 251 million COPD patients are there. So what is the gap that what identified? That by 2015, 3.17 million death, which is a 5% of the total, and over 90 of the middle and low income countries, just like abnormal inflammatory responses and progressive environmental pollutions, use of tobacco, and the treatables only when detected early. There is no mean of proactive identification, and there will be by 2020 the third largest cause of the death by using the COPD or let's say TB. Okay, so the current stage I patented point of care tool of the COPD screening, that is a TBN. So basically what it does and what is this focusing this lung based element screening. So it is doing the screening of the lung by using the cough sound of the patients. And this all those things are done by using these three different technologies: IoT, fog, and the cloud. So here you see the framework. That is what happening over here. So let's say the patient is having a that coughing voice, that what is it is collecting by using the microphone array, and there will be the interface, let's say mobile interface, which is already having like this data analytics and machine learning, deep learning techniques, and this all the data that will be goes to the EMR, that is the electronic medical record, or you can say another is a cloud. Okay, and that can be used for the pre-diagnosis to determining the drug sensitivity and resistance. And what are the results that you can see? The results will be useful to refer to the partner agencies or other physician agencies to diagnose, or the other diagnosis lab to get some solutions. Okay, and the results also shared with the individual along with the next step process. So let's say there is a patient involved, there is a physician involved, there is a laboratory people are involved, the relatives of the physicians are involved. The whole results will be shared with them, and that is what one of the most benefits. So here you see like we are collecting a cough sound of the patient, and by using these three different technologies, just like IoT, fog, and cloud, you can get the solutions that you can reach out to everyone at the same time. You don't need to transit anything, and you can do this all kind of care remotely, because what patient need is just need the microphone and the mobile phone devices. And by using these two tools, that it can reach out to the laboratory, it can reach out to the physician, it can reach out to the relatives at the time he or she needs the care and solutions. Okay, so the outcome is a person or patient's cough and demographic, clinical, socio-economic variables that can be captured and that can be used for the treatments as well. The other research project that we are involved with by using this three different technology, which is the IoT, cloud, and also the fog, that are like the cyber solutions. So here you see the cyber test and automation rather. So what are the cyber test and automation system over here? So here you will be seeing like the problem domain and the solution domain. So here it is little interesting. Up to now we have talked about like three different technologies, but over there the applications is the healthcare. Here we are not talking about the healthcare. Here we are talking about the solutions of the cyber security. So how we can use this, but cloud computing and let's say IoT or fog computing for a cyber test autonomous system. So the first one that you will be seeing over here, that this is the problem domain and this is the solution domain. So the problem domain that you are seeing here, that there is a virtual machine host and there's a normal virtual machine and there's the infected virtual machine. So what does it do? The virtual machine host, that we call it as a hypervisor, and the hypervisor is having like two different types of virtual machines. The first one that you see is the normal virtual machines, and the second one is the infected virtual machines. But let's say if you have the antivirus, which is running on the operating system, and the collecting a data which is given by operating system, and uh, those antivirus will be scanning and giving you the result that, oh, there is no single virus or there is no any single threat within the systems. But actually, if you see, there is a threat. The specific rootkit, which is hiding itself from the operating system, and it stores everything like viruses and opening a backdoor for the malware and viruses to get enter into the system. So in this problem domain, you can see that if you are using antivirus, it is not easy to detect a rootkit. I mean, it is impossible to detect rootkit. So in that case, what is happening over here? That the hypervisor that we are using, and the hypervisor is having the virtual machines. And that hypervisor is using one specific tools that we known as an introspection, which is looking into the directly virtual machine memory, and then that virtual machine memory also includes a kernel memory. Obviously, the rootkit cannot hide from the introspections, and it can easy to detect whether the rootkit is sitting within the kernel or not. And it will also allow you to collect all memory data and then transfer that data to the network server for machine learning analytics. And you can do like two types of analytics. The first one is the classification, and the second one is the anomaly detection. Data can be also used to build a new machine learning models and then compare them against the existing model. And then you can do the existing model comparison with the new model and do the classification whether the system is infected or not infected. So that is what the cyber test autonomous system. This is not only work with the single Windows or Linux solutions. Here, let's say if you have IoT devices, you can propose and do this kind of solutions. Here, let's say if you have a fog within the device itself, yeah, there is also chance that rootkit is sitting over the fog and trying to manipulate some data and manipulates the results. So that all that you can detect by using these introspections, and that is what one of the benefit of these solutions. The another project, which is known as the security and privacy of the social media. This project is very informative projects that we have developed, and this project is having a really big impact. So the best impact that I could say about this project is there are so many solutions and tools available in the market, just like a social media market. Okay, but let's say, for example, if somebody is putting some information about the company and businesses over the social media, is there any way that we can detect if there is any security and privacy of the social media is leaking? So there are no such kind of solutions are available right now. So here what we are doing, like we are proposing the solutions, the security and privacy of the social media. And these solutions are giving such kind of business solutions and useful for the commercial and business social media only. Okay, so how does it work? So let's say if there is any company or there is any business where they are using the social media to do the marketing of their products and their content. So let's say, for example, there are employees. who are creating the content of the social media. Once they create the content of the social media, that can be a different types of content, and that is going to this collaborative trustworthy cyberspace. That what you are seeing here. In the collaborative and trustworthy cyberspace, what it does, it is doing three different types of things. The first one is the security privacy management. Second one is the trust evaluation, and it also perform natural language processing and reinforcement learning algorithm to check all this security and privacy management. There are list of hundreds of the security and privacy management that you can incorporate by using these solutions. But let's say, for example, if there is a data leakage, there is an identity theft, there are fake request apps and links are available on the link on this post of the social media. If there are some risk in the sharing that information over the social media, there is also reputation issues of the company. Let's say if some employee is posting something about a company or their product on the social media that may dispute the reputation of the company. There are also some issues related to the legal and compliances, and there are also some operational and behavioral issues and security privacy management issues, and other different types of issues that you can incorporate by using this collaborative framework. And the natural language processing and reinforcement learning, what does it use? It is checking the content over the social media, and it is identify if there is any such kind of security and privacy is missing or its leakage, and then it is giving immediate alert to the administrator who is monitoring all these kind of things. The trust evaluation is very important part. So the trust evaluation, let's say for example, if I'm working in a company, so let's say I have started working in a company, so I might not be familiar with the each and everything about the company. So when the trust evaluation has been performed, my trust would be the company's trust in me would be little less compared to the person who is working since long. So based on those different criteria, like number of experiences, number of years experience that that person is having in the company, the number of projects he or she has been involved, the number of training of the security and privacy and cyber security and compliances that the employee has gone through, that all these things collects together, and then it is evaluating the trust. And once it evaluates the trust, it will identify whether the content is appropriate to put over the social media or not. And then it will go to the social media. So that is what the privacy and security of the social media, and that is what the high impactful proposals that what we have been funded and we're working on. So the research finding that you are seeing here, that it provides the security and privacy of the social media based on the given criteria. It also check, validate, modify, delete content, add content, and also assign multiple viewers to review the content of the social media. And it also automate the security and privacy evaluation using NLP and RL. These are the research findings, outcomes, broader impact of this framework of the security and privacy of the social media. The another project that I would like to mention a little bit about is a wound monitoring. But before I go for the conclusion, let me discuss about that wound monitoring project. So the wound monitoring project is more about the project. So let's say if somebody is having some little kind of wound, okay, some accidents and they have that kind of wound. So what they need to do, they need to go to the doctor. Doctor is using the bandage to put on that wound, and after 1 or 2 days, he has to go again to the physician or doctor to check the progress of the wound recovery. Okay, so what is a wound monitoring we here? So by using the solution of the wound monitoring, what we are proposing, that patient, he or she doesn't need to go to the doctor or the physician. Okay, so what they are doing, like they are using the smart wound monitoring system, which is a sensor based bandage, and that does all this kind of work. let's say continuous monitoring of the patient situations, and their progress of the wound recovery and everything. So that is what all about the wound monitoring solutions. And that is also we are doing by using these three different technologies. The one is a IoT, second is a fog, and third one is a cloud. So let's say the IoT would be the smart wound. Okay, the cloud, which is collecting the wound data and storing the anonymous data, and the edge itself implemented. So wound will be having the computation, which is continuously collecting and computing the progress of the wound recovery, and reporting to the physicians or patient and also the relatives of the patients. So that is what all about the wound monitoring project. So by discussing all these projects and the concepts with the examples, I would like to conclude my talk with the following out list outcomes, that the artificial intelligence and the data science becoming very popular in various fields like information security, sports and fitness, and health monitoring. So let's say, for example, if you are talking about the IoT, you have to incorporate artificial intelligence and data science. If you are talking about the fog, you have to apply analytics and computation. And if you are talking about the cloud, with the storage, you have to provide this facility of the analytics. And the field like information security, which is the cyber security as well, the sports, fitness, and also the healthcare monitoring. You can also see the digital health cybersecurity is also a state of art and yet need to be explored in the field of medical and biomedical. So let's say, for example, if you are talking about these three different technologies, the most frequent application that I can ever state in the current era and days is a medical, or let's say digital health. Okay, so that is also you need to explore. Let's say, for example, Apple Watch is collecting your data. Okay, but how much it is secure to you know collect the data by using those wearable devices? So there is also a need, or the need of the workforce, that can study about like what are the security issues and security parameters, and the cyber security issues are associated with this specific social media. Okay, sorry, the specific solutions that is available in the market as a wearable devices. The another one is a big amount of the data floating over the social media can be extracted to generate essential knowledge and the decision making for medical science. Obviously, the lot of data we are collecting about the hearts, about the blood, about X-rays, about everything. So there's all different types of data that can be used by the medical experts to do some research in the field of the medical science. So you will be seeing, like, let's say if you want to have the X-ray images of the data or any other data related to the medical, you can simply go to the md.ai website and get all the data set to do the experiment of like AI and machine learning algorithms. So that is, one kind of like opportunity, or that, all this big data available and floating over the social media, and also like, other websites and portals that can be used to generate some essential knowledge and can be useful for decision making in the field of the medical science. The another one is the developed and presented research project in this presentation have many intellectual merits and the broader and the wide broader impacts. However, there are many other associated areas needs to be explored. Okay, so what are the other research, other associated areas? So you will be saying, like, we have discussed about the IoT, fog, and cloud, but we haven't talked about like autonomous car. So there are a lot of research going on. So that is also the collection of these three different things. That the car is collecting the data, storing the data onto the cloud, doing the computation within the flow, and it is also using the high bandwidth internet. So just like a 5G. So we are predicting the field that by using the 5G network, it will be easy for us to provide the communication between two car, which is a autonomous car, for example. Okay, so these are the all different fields that can be explored and that needs to be explored. The another one is like we can customize a discussed IoT AI framework to diagnose the presence or absence of the pulmonary tuberculosis, that is what TB, and also detect the changes of the diabetic patients by ratings, predict heart attacks in advance, and many more others. So the solution, like this health IoT health monitoring that does all these functions that is discussed here, but there are also like potential functions that can be developed by using the same solutions or the framework and can provide the best facilities to the digital healthcare and marketing. Okay, so this is what all about the the today's presentations, and in last few lines, if I would like to conclude, I would say like the IoT is a field that is happen that is required to get some attentions of the other field connected, just like fog computing and the cloud computing. And this fog, cloud, and IoT, they are not complete without using artificial intelligence and data science and other machine learning like classification, regression, and deep learning algorithms.
Okay, sir.
I'm
Thank
open
you.
for any questions.
Uh, yes, sir. Now I request participants, if you have any question, please ask. Okay, I'll check the chat box. Okay. Sir, one of the questions is which type of sensor used to decide the data is anomalous?
Basically, sensor is working on the prediction. I mean, pattern recognitions. So basically, these nano sensors and biosensors. And nowadays, like already ready-made sensors are available in the market, so you don't need to develop your own sensors as well. But this all like nano-enabled sensors or the biosensors that you can use to predict the pattern of the human body or the temperature or let's say any disease. And additional thing is like you can incorporate machine learning techniques so that will detect whether there is any anomalous behavior. So as I have given the example that biosensor is collecting the data. So what kind of data it is collecting? Let's say heartbeat data. But how would a sensor know to generate the alert to the physicians or to the patients or to the relatives of the patients when there is a, let's say for example, um, some anomalous behavior? So that for that obviously you need to do the pattern analysis, right? And the pattern analysis can be done by using AI and machine learning. Yes.
Okay, sir. The next question is what type of sensor is used for cough sound? Is it a non-contact type or non-invasive one?
What kind of sensors?
Is used for cough sound.
Okay, so that basically we haven't used any sensors for that. We have used the microphones to collect the cough sound data.
Okay, sir. Okay, next question is can you elaborate how rootkit cannot hide from introspection and how hypersaver secured?
Yeah, basically, why rootkit cannot hide from the introspection. The reason behind that, basically, what happens that rootkit is sitting within the kernel space, and the kernel space is cannot be monitored by the antivirus, but the introspections is watching into the memory. And why hypervisor is secure, that also answer coming in this talk that I'm giving. So let's say hypervisor is specifically assigning a memory space to that specific virtual machine, and if it sees that there is misuse of the memory is happening, so hypervisor can easily identify it. And another thing is like introspection is sitting over the hypervisor. It is not sitting on the operating system. So let's say if you are getting the data from the introspection, it is sitting on the host, which is the hypervisor. So here you see that operating system can be easily manipulated by the rootkit, but obviously the introspector, which is sitting on the hypervisor, cannot easily manipulated by the any rootkit which is seated on the kernel of the virtual machines. And that is the benefit, that it is secures. And I mean, yeah, and rootkit cannot hide obviously from the introspector, because introspector is continuously watching the memory area and the kernel area of the virtual machine.
Uh, okay, sir. Next question is, please share outcome of one project who develops the sensor. I guess.
What is that?
Please share the outcome of one project.
All the project.
Und one monitoring.
Wood,
I'm missing
wood
words
monitor. Okay.
to ask.
Yeah, exactly. Yeah. So the the outcome of the wound monitoring project is like it will give you monitoring a wound remotely. So patient doesn't need to go to the that physicians every 2-3 days or whatever the time period. At home, the wound itself, the smart that bandage, the smart bandage that is collecting the wound data regularly and check the progress, that how much at what percentage level the wound is monitored. And once the wound recovery is 100%, or let's say 95-97% accurate, then yeah, you can go and visit the doctor and they can remove this smart bandage and you are good to go. Or you can simply remove the bandage, so you don't need to go to the doctors. So the thing is, like, wound can be monitored remotely, and that is the actual outcomes of that smart wound monitoring system.
Next question is, you speak cognitive solution in drone. What EEG signals recollected? What application it is?
Basically, the cognitive solutions. I mean, the thing is, like, bio in the senses, we are not collecting any kind of signals. But you are talking about EEG. Okay, fine. So basically, in EEG, the solutions, the signals that we are collecting is about the let's say, for example, the analog signals of the movement or the body. So let's say if somebody is behaving like this way, then what kind of human temperatures it is collecting. So it is I mean, there's a sensors is collecting like various signals, but the mostly that we are collecting right now is the heartbeat and the movement of the body movement, and also the temperature of the human body. Yeah, so these three things we are collecting.
Okay, sir. The next question is, can you give suggestion for possible COVID-related challenges using IoT?
Possible challenges is one thing, like nowadays, what we are facing challenges is, like, let's say we would like to apply a deep learning on the fog computing, but due to like computational limitations of the fog, you cannot apply a deep learning over there. So that is what, like, one of the biggest challenges nowadays, because compared to machine learning, we people are believing like fog I mean, this deep learning is giving more accurate results in sense of the predictions and model training. But the thing is, like, it is not possible to put the computational on the fog that can compute the deep learning. So that is one of the challenges, the biggest challenges, you can say.
Okay, sir. Next question. I'm not taking the non-technical question. Next question is, can you suggest a good fog computing simulation platform?
um Good cloud compute, what was, oh,
Fog
fog computing
computing
simulation. Yeah.
platform.
Yeah, exactly. So I would suggest, the if you are looking for the open source, there is a Google Cloud. which is providing the fog computing simulations. Uh, Google Cloud Services, yeah. But I would suggest to go with Microsoft Azure. So Microsoft Azure is having the fog and edge computing simulation, and it is also providing tutorials and free sample computational data. So that's what I suggest to go with.
So next question is for biomedical sensor, what is the minimum voltage requirement and sensor examples?
Basically, I mean, there is no minimal voltage requirement that I'm familiar with. The reason behind, like, I'm closely working with the electrical engineering people, so they are working with this, voltage and this electrical things. But the sensor example, as I have mentioned, that the one that I would suggest is a nano enabled sensors. So that is one, and another one is a that heart biosensors, which is computing. I mean, collecting this EKG, EEG, motion capturing. So these are the examples of the sensors that you can say.
Okay, sir. I'm taking the last question. Can you explain the own sensor used, its specification or the company?
No, basically, I mean, we haven't used any ready-made wound sensor, but as I mentioned, that I'm closely working with the electrical engineering people here. So we have designed and developed our own wound sensor. So basically, like, by applying this biomedical, techniques, they have designed and developed this, smart wound. And what it does, like, it is continuously watching screen temperature and the hardness of the screen. Okay, so let's say if it is like more moisture, then the wound is still not getting recovery, but the moisture is getting down and the hardness is getting up, then that means there is a recovery. So that is the preliminary results that we have designed and developed so far.
Okay, sir. I think we don't have no. I mean, we don't have the questions. So, thank you once again, sir, and good night because at your place it is late night. So, thank you once
Yeah,
again.
no problem. Yeah, thanks for inviting me, Dr. Nagendra. And if anybody is having any questions and concerns, they can send me an email and
Yes, sir.
reach me out through Dr. Nagendra as well. Thank you.
Okay, sir.
Thank you
Okay.
so
Thank
much.
you very much, sir. Okay. Thank you, sir.
Yeah, thank you. I wish all of you have a good day. Namaste.
Thanks. Namaste, sir. Okay. So I have
Shah sir,
announcement. Yes,
can
ma'am.
you share the contact details of Dr. Hardik?
Sure. No, no issue, ma'am. Definitely, I'm going to share.
We would like to have him for a session in our place, so if it is
No,
possible.
no issue, ma'am. Definitely, I can share.
Thank you.
Okay. So I have a small announcement. The test is going to begin at 7:30 in the evening, and it is only for half an hour. I'm trying to only put 20 or 22 questions, nothing more than that. Okay, and we will meet at 12. If you have any doubt, you can ask now. Okay, one more announcement that many of you have joined many sessions with different names, right? So I'm going to circulate one of the Google Sheet in which you can uh, write your name by which you have registered for the FDP, and you need to give those names or those email IDs from which you have attended it, because there is a lot of I mean dissimilarity between those names which we have registered and the names we have attended. Like someone has attended HOD something, this college, right? So so that is very difficult for me to give you the attendance. Okay, 7:30 to 8. The test time is 7:30 to 8 in the evening.
One question, whether are you going to circulate this Google Sheet through mail or in the chat box of the meeting?
Ma'am,